Hey everyone! So in today's lecture, we are going to be looking at the actual practice of propagating by cuttings. So we're going to be looking at a number of different types of cuttings that we can do. Now we're going to start with stem cuttings, and within stem cuttings, we can have hardwood, softwood, semi-hardwood, or herbaceous cuttings. And then we'll look at leaf cuttings, leaf bud cuttings, and we'll end by looking at root cuttings. But before we get into that, I want to take a couple slides and talk about the propagation environment for cuttings. So one of the important things is that we need an environment that has high humidity, right? Particularly when we are looking at our softwood cuttings or semi-hardwood or herbaceous. The reason is, and when we're looking at stem cuttings, right? And the reason is that we are taking a portion of the stem, and when we're doing that, we are severing the connection to water, right? We are removing the root system or the larger part of the plant. So now that plant does not have a viable way to obtain water until it grows roots. So in the meantime, that plant could still be transpiring. It could still be losing water, especially if it's a softwood cutting, right? That has leaves, etc. So when we are doing this, we want to maintain a high humidity environment to prevent the plant from losing water until it has the appropriate amount of time to establish roots and begin taking in water like it does normally, right? So as a result, there are a number of ways that we can do this to maintain humidity or a wetter environment. And we'll look at some in the lab that comes with this lecture. I will show a propagation system that you can do at home, a real easy one. But it could be something as simple as, wrapping your cutting in plastic sheeting or a plastic bag, right, to maintain that humidity. They make small little propagation domes and chambers. If you're doing something outside, you can establish some sort of misting or sprinkling system that is automatic, all to maintain this humid, wet environment for your cuttings until they can establish roots. So one thing we want to be aware of. Another thing is the media that we use. So for cuttings here, it's going to be slightly different than a soilless media that you would use to grow a plant from seed, or if you were transplanting. Um, and this is for a couple of reasons, right? So if we're looking at the media that we want to use for our cuttings, it should be sterile, and that's true for our, standard soilless media as well, right? Because we want to prevent diseases, especially now we have a wound if we're taking a cutting, so it's more susceptible to potential diseases, at least initially. But where we have a difference here is our media for our cuttings should be low in fertility. So it shouldn't have a lot of nutrients that we would expect for a different type of media if we were growing from seed, etc. And this is because that fertility is going to promote top growth. So it's going to promote the growth of your shoot system and leaves, etc. And we don't want this to occur too soon because we don't want that to happen before our rooting system has established. And again, it's for the reason of water loss, right? If we have too large of a shoot system, too many leaves, they're going to transpire, they're going to give off water, and there's not going to be the root system isn't going to be established well enough to be able to take in the water that gets lost through transpiration. So we want a low fertility initially. We also want our media to hold water, just like with our regular, but we don't want it to hold too much water, right? A traditional soilless media that we talked about way back in seed propagation is likely going to hold a little bit too much water. It's going to be too moist. That excess water won't be taken up by roots because initially there are no roots. And it could lead to your roots or your stem or your cuttings rotting, right? So instead, we want something that has a little bit more drainage. So examples of common media that is used, probably the easiest one is just coarse sand. So that's a picture of it up there. It almost looks like little rocks, right? It's different from play sand that you may find in you might get at a store or something like that. You want it a little bit with a little bit larger grain size. So coarse sand, coarse vermiculite, right? Vermiculite is often included in these soilless mixes, like your standard ones. You can do a vermiculite and perlite mix if your vermiculite is a little bit more fine. 60-40 is recommended, but people have different mixes that they use. A peat and perlite mix or a peat and sand mix are also effective, or just in some cases just plain water. That's kind of more common in like your herbaceous cuttings. But any of these can be used as a media in which to propagate cuttings. In the lab, I am going to show you, I have one where I'm using sand in one setup, and then in the other, if I was using it, and I'm going to use it later on in the year when it's time for softwood cuttings, I'm going to be using vermiculite in that as my media. One other thing that I want to talk about before we get into the cuttings is auxin. So auxin is a plant hormone, and amongst other things, what auxin does is it promotes rooting, right? The development of roots. And we have synthesized auxin and we sell it commercially as a rooting hormone or a rooting compound to use with cuttings. And there are different brand names. There's 2 examples down there on the bottom. And it can come in a liquid or powder or gel form. I guess people probably have preferences for what they like. Some people probably prefer gel or liquid or powder. I haven't used the gel before. I've used both the liquid and the powder. I don't particularly have a preference. Both have worked and have been effective. So I think it probably comes down to, as you do this more and more and more, you'll probably kind of find one that you like. But in general, this auxin, or rooting hormone or compound, as you'll see it when it's being sold, can aid in root development, particularly for tough to root plants, right? So we looked at in the last lecture, in the development of our roots, some of our cuttings, some of our plants have those latent root initials. They're going to be easy to develop roots. You don't necessarily need to use an auxin or a rooting compound with them. So the wound-induced roots are typically the tougher plants. It's tougher for them to root, for roots to develop. So with those plants, it might be more beneficial to actually use a rooting hormone. Although some people use it for everything. It can come in different concentrations. And again, if you're using something that is easier to root, you're going to want something more in the 500 to 1,000 parts per million, or about 0.1%. That would be what you'll see on the actual bottle itself, right? It'll say 0.1% of whatever auxin it is. And they come in different, auxin's like the larger name. There's actually different chemicals for each one. For something that's harder to root, it's going to be around 5,000 to 10,000 parts per million that you're going to want to use. And to use it, very, very simple. You would take your cutting. Before you plant your cutting in whatever media, you're going to dip it into the compound for 1 to 5 seconds, and then you're going to plant. And a quick tip, if you're using like the powder or the gel form, or I guess even the liquid form, don't dip it directly into the container that you see here, right? You would pour a little bit of this out into a different container or a shot glass, and then dip your cutting into that, and then into where you're planting. And also make a hole of where your cutting is going to be, because you don't want to push into that media because it may kind of scrape off some of the compound as it goes into the soil or soilless media. But the reason why you would not dip into your container is there's the potential that you would transfer pathogens or contaminants into that container with each cutting. So to avoid that, pour a little bit out into something else and then dip into that. So those are some considerations before we get into our cuttings. And now we're going to start looking at our different types of stem cuttings. And we're going to start with hardwood cuttings. So hardwood cuttings, these are cuttings that are taking from mature, dormant wood. And we will take these cuttings anywhere from kind of fall, particularly late fall, through to early spring. right? And this is wood if it's our deciduous trees. This is how you would identify this type of wood or this type, cutting, is that it's going to be a plant that has no leaves on it, right? The leaves are falling off, or if there are leaves, you can easily pull them off, right, without ripping any other wood material. So examples of species that we can propagate through hardwood cuttings or commonly are willows, very, very common, especially for some of the restoration work I do. Poplars, rose, dogwood, grape, pears, all are propagated or can be propagated through hardwood cuttings. Now, when you're taking a cutting from a tree or shrub, it is best to take juvenile stems. So this is something that's pretty interesting. It's sometimes called the cone of juvenility, juvenile, whatever that word would be. But you need to think of it as the difference between chronological age and physiological age. So chronological age would be just age in time, right? So when the plant is young, right, it's producing tissues, and as it's growing, you got to remember that the growing points are at the tips of our shoots right here. So the tissues that are produced up at these growing points up here are chronologically the older tissue, or the youngest, youngest tissue, right? Because when it was still young, it produced this tissue down here, right? As it got older, it is producing, so this is what it was produced long ago, and this is the new tissue that is getting produced up here, right? It gets a little complicated, but, right, the newer tissue is produced at the tips of our shoots. So chronologically, that's young, right? It's the newest tissue that's being produced. But physiologically, it is the most mature tissue, right? Because way back when it was a young tree, it was producing juvenile tissue. And then as the plant ages, it actually goes through a life cycle like any organism, and it goes from juvenile to mature. So eventually, when we get all the way up to here, right, the current stage, this new tissue that is being produced is mature tissue. So hopefully that makes sense. So if we're going to take cuttings, from a mature tree, it is ideal that you're going to want to take cuttings from the more juvenile tissue. In the juvenile tissue, it's more likely to root than some of your mature tissue, depending on the species as well. So something to be aware of. And then last thing that I have here is our hardwood cuttings are slow to root, right? These are, if you take cuttings in the winter time, late fall, even early spring, it's going to take several weeks to months to actually develop roots. And that's because this tissue, it's mature, it is dormant wood, right? So it's going to take a while for that dormancy to relieve and then to actually start growing and developing roots and eventually a shoot system. So in practice, what do we do? Well, you're going to want to take a cutting that can really vary anywhere from about 4 inches to 30 inches in length. Your hardwood cutting, typically you're going to want something around 6 to 8 inches in length, and that's something that's about 1/4 of an inch up to an inch in diameter, right? So if you think about a pencil diameter, that's kind of like a good reference point. You want to take growth from that year, right? So you want growth that has occurred. If you think that new growth develops in springtime and then it matures to semi-hardwood, which we'll look at, and then eventually in the winter it becomes mature dormant wood, you want to take that growth from that year rather than a stem that was grown several years ago. And then when you're taking your cutting, you want to make sure you include at least 2 nodes. So nodes are really just junction points that are the base of buds or new shoots or new leaves, right? It's these, if you're looking on hardwood tissue, you'll see little bumps. Sometimes you'll see the actual buds right there. So each one of these would be a node. Sometimes you don't have the buds here. You'll just see a little bump and a little bump. And those are your nodes. So you want in each of your cuttings, you want at least 2 of these. So you would want at least, if you were making a cutting, you would have a cut here and a cut here, and now you have at least 2 of these nodes. In practice, you're going to want to make a horizontal cut right below your bottom node, and then a more slanted cut about an inch above your top node. And that you do that to protect that bud down here. Right, so you can make a cut right here, and then another one here. And the different angle of cut is going to help you identify which end is which, right? To ensure that you keep the right polarity, right? So if we're going to have roots growing from the bottom end and a shoot system growing up from that top end, so you maintain your polarity in that way. I think there are also some benefits of this angled cut being on the top here, but I'm not positive. Okay, so you take your cuttings, and then you're going to plant them into either an outdoor bed that you see here, or a propagation structure that I'm going to show you in the lab. So hardwood cuttings, taking late fall, winter, early spring. We then have our softwood cuttings, and all of these cuttings that we're going to be looking at are coming from your woody plants, so your shrubs and your trees. So we call them softwood cuttings. They're technically coming from your woody plants, but this is the new growth that is developed each spring, right? And it's going to be soft and succulent that you see there, right? It could easily bend. It won't break if you bend it on itself. You're going to want to take this in late spring. So around here, you're going to want this in end of May, June. You're going to want to start taking your softwood cuttings. And you'll see, if you pay attention to your plants, if you're looking at your trees and your shrubs, you'll see this new growth start to occur relatively soon, right? And our new, you'll see at the, you'll see along your stems, this new growth developing. And that is what you're going to want to be taking. Now, your softwood cuttings are going to root much faster than your hardwood cuttings or even your semi-hardwood cuttings that we're going to look at later. But just like with the cuttings, you're going to want to take, with the hardwood cuttings, you're going to want to take something about 6 inches long. They say you can get as small as 3 inches, but around a 6-inch long cutting. And you're going to want to trim the lower leaves. So this is a blueberry right here. If we were taking this as a cutting, again, you're going to cut right below a node, so we would be, probably like right around where his thumb is. And then you would trim up all these leaves, leaving at least 2 of these upper leaves, maybe the next set as well. And you're doing this because those leaves are where that transpiration occurs, and you're worried about that water loss like we talked about. And then you would take your cuttings and put them into a propagation structure. Again, something like I'm going to show you in the lab. Also, I mentioned this, but with all of these cuttings, you can dip them in a rooting hormone before you do it. Then we move to semi-hardwood. So we have our softwood. It's developing in the springtime. As it goes through time, that wood is going to begin to mature. And the semi-hardwood stage is this transition between initial softwood to mature, dormant hardwood. And how you can tell that it is semi-hardwood is with this bending it on itself, right? So if you have your stem here and you bend it on itself, if it's softwood, it'll be able to bend completely back on itself. If it is semi-hardwood, it will bend back on itself, but it will eventually snap, right? And that tells you that it is at the semi-hardwood stage. Hardwood won't really be able to bend. So at a semi-hardwood stage, it's going to take a little bit longer to root than your softwood, but not nearly as long as your hardwood. And how you propagate softwood is going to be very similar for the semi-hardwood as well, right? So this is stuff that you're going to take in late summer through fall. Again, you want a cutting that's about 3 to 6 inches long. You want to cut that lower part below a node. You will trim your lower leaves, again, just like your softwood cuttings. And you're going to plant it in any sort of propagation structure that you have set up, right? So very, very similar. It's not a very hard, complicated process. It doesn't have to be, right? You take your cutting, dip it in a rooting hormone, put it in your propagation structure. In the case of these softwoods or semi-hardwoods, trim the leaves as well. And now we're going to go to herbaceous cutting. So this might be commonly done with your chrysanthemums. These are herbaceous plants, are non-woody plants, right? So we're out of our trees and our shrubs that we were looking at. These types of cuttings can be taken year-round, where you don't have to limit it to just one time of the year. Typically, you want a cutting about 3 to 5 inches long. Just like with your softwood cuttings, you're going to remove those lower leaves. Um, with a lot of herbaceous cuttings, you don't need to apply an auxin or rooting hormone, but it can help. And something that if you were doing this with succulents is you may want to leave your cuttings for a couple hours up to overnight to suberize. So suberin or suberin is a waterproof compound that gets is used by our plants to essentially seal off wounds, right, and prevent them from water loss. So if you make your cuts of your succulents, that'll suberin will form along that cutting, seal it off, protect it from water loss from pathogens, and then you can then plant it in whatever media you're going to use. So I have a quick video that I did last year with pea shoots, and we'll take a look at that. Let's do our pea shoots. These guys are real easy. I'm just going to put about a ½ inch of water in the bottom of this mason jar. I'm going to take our shoots. Do essentially the same thing. I'm going to make a couple cuttings. Just like with all of our cuttings, you want to cut just below a node or a bud. So we're going to cut right there. Ooh, that's kind of tiny. That's tinier than I thought. We'll give them a little dip. 1, 2, 3, 5. And then we'll place them in the water. Alright, now we're going to move on to leaf bud cuttings. This is a type of a leaf cutting, but you're including a little bit more, right? So if we had, let's see, here's our stem, here's our leaf. Right, so this is the leaf right here. This is the blade of the leaf, right? This is the petiole. And typically there may be a bud or something right there. When you're doing your leaf bud cuttings, you're taking not just the leaf, but also a part of the stem into which it's attached, like so. Right, so you're taking the leaf. Oops. If I could spell that correctly, you're taking the leaf, petiole, and then part of stem, which includes this bud or the base of the bud. Includes bud or base. Right, so you're taking a little bit more than just the leaf. You will see this with black raspberries. They will take leaf bud cuttings, blackberry vines, blackberry rhododendron. I'm not even going to try and spell that one. Right, so it's a type of leaf cutting, but instead of just taking the leaf, you take a little bit of stem as well. We also have leaf cuttings. Oops, I don't know what I did there. Leaf cuttings, where we're just taking the leaf in our leaf cuttings, right? So we're just taking either the blade of the leaf, like so, we'll just take the blade, or if there's a petiole, we can take the blade and petiole. And there you can just take, in some species, you can take sections of the blade, right? And each of these could be a cutting. So here I have a Sansevieria leaf,
And I actually haven't watered this plant in a while, which isn't the ideal time to do cuttings, but we're going to give it a shot. So you see, here's the leaf right here, and from that I took a couple cuttings, right? And these are leaf cuttings. And the cool thing about this plant is that it has the ability to develop roots and new shoots from these sections of leaf. So from here, what you would do is typically you can leave these out. You can make your cuttings and leave it out for a little bit. These wounds will get superized. That's where that waxy compound will help protect them. And then you can put them in whatever media you're going to use to propagate. So for this, we are going to try just using water. So I've got a little Tupperware filled with water. You could use a mason jar, whatever you got. And remember, we want to maintain polarity, right? So this is how the leaf was growing. So our bottom ends essentially are where our roots are going to grow from. And actually, in this case, what's going to happen is our roots are going to start growing from here, and then a new shoot is going to grow from this end as well. So you're going to make sure you put them in the right way. So you take your cutting, and then we're going to drop it right in the water. And we'll just leave it like that. I'll put that one over there. And we'll throw this one in right over here. And we're going to keep them in there, and we'll see how they do.
All right, and last, we are going to look at root cuttings. So these are best taken in late winter or early spring. You're going to want a cutting that is about 6 inches long, and you want to maintain polarity. So we talked about polarity in the last lecture. That's that idea that our different sides, our different ends of our cuttings can react differently. So with our roots that are growing down this way, if we take a cutting here, right, we'll zoom it in. This is our cutting that we took. This top end up here is going to react differently than the bottom end. So if we're going to plant this, we need to plant it in this direction, because the new adventitious roots are going to grow from this end. Roots from this end, and our shoot will grow from this end. All right, so just so you see it more clearly. Did that work? Come on. So you see it more clearly if this is our green end over here. Here's our green end here. This is our red end down here. Red end down here, right? So because of how this cutting was taking, this red end, this further end of our root, is always going to be where our new adventitious roots form, and this green end is going to be where our shoots form. So if we planted this the other way, where our red end is up here and our green end is down here, we aren't going to see successful propagation, because our roots are going to start growing from up here and growing down, and this is going to want to grow a shoot system. You don't want to do that. So you want to maintain proper polarity. You can do this by angling your cuts on one end and keeping them straight on the other end. So if we took a root system, if we had our root growing down here, we'll make an angled cut on the top here, and we'll know we're going to grow our shoot from there and plant it that way. When we'll have a flat cut down here. Another real easy way to do this is just to plant these guys horizontally, right? And then you don't even have to worry about it, because if you plant it horizontally, your roots will grow down here, and your shoot's going to grow that way. And I have, I did some cuttings of beach plum that I took, and you can see some photos here of the cuttings that I took, and hopefully they will root sometime this year. So the last thing that I want to look at is some other considerations when taking cuttings. So idolation or banding can be beneficial for some species. Maples, pines, rhododendrons, sycamores, these are maybe some more difficult to root species. So what this is idolation is the total exclusion of light, right? In practice, it may not be total exclusion, maybe just shading, right, when we're talking about it. But like I said, this can improve rooting in difficult to root species. And how it works is you would apply a shade over your stock plant, the plant that you're going to take your cuttings from, in the springtime when it's going to start developing its new softwood. So so as that softwood is growing, it's going to be growing in the shade. Eventually, you're going to remove the shade and you're going to apply some sort of Velcro band or even just like electrical tape to a spot where you're going to take that cutting to completely shade out any sort of light, right? You allow your shoots to green up, right? Because now they're exposed out of the shade. And then once they green up, you're going to remove the cutting right there where you had placed your band. You then dip it in your Auxin, put it in your propagation system, and hopefully it roots. All right, and as you see here, that for the species, for the varieties taken here, that you see a big difference in the rooting in the ones that were idolated versus the ones that weren't. Right, and there could be a couple of different reasons why this is happening. By doing this idolation, we may be enhancing the stem's sensitivity to auxin, or reducing the production of lignin, which is a compound that creates that hardwood. Right, so either of these things or both could be occurring. But you can see for certain species and for certain varieties, there is a difference, and you see much better rooting if you do this process. So something to consider, particularly if you're going to look to use cuttings on maybe maples or pines or sycamore or rhododendrons. And the other thing that I want to talk about is wounding. So some people will wound the base of their cuttings, right? You are wounding the cutting, you're wounding it initially, right, by taking the cutting, but then they will further strip off a little bit of bark as additional wounding. And again, this is beneficial in certain species, like rhododendrons and juniper, for example. But I've seen people do it for just everything, right? They take their cutting and wound it. And the benefit, or what's happening, is that it may stimulate cell divisions and the production of root primordia at that base, is what you want to do, right? You want your new roots developed. And what may be happening is when you're doing this additional wounding, there may be an accumulation of auxins, naturally, that root-producing hormone, and carbohydrates in that wounded area, and that could lead to better production of roots. So they've seen that in some species when they've done studies on it, and others they actually don't see that big difference. But it is something that can be done, particularly for certain species, or for all if you want to try it out, to maybe aid in the development of roots. So that is that. Some practical methods for taking cuttings. In the lab, I'll show you a little simple propagation system that you guys can do if you're interested in doing these types of cuttings at home and you don't have any other setup done, right? If you don't have a greenhouse, if you don't have any other kind of propagation system. So take care, and I hope you guys are doing well.